welcome.
Thanks, Michael. Is that a decent volume? Thank you for having me. I'm probably on my fifth cup of coffee, and I get a little chatty, as my wife says sometimes. So I've a number of things that I want to kind of hit on from a sort of introductory standpoint on what AWS is and kind of the things we get to do within higher ed. I do want to take a moment and say thank you for having me. I also want to, I don't know the best way to say this, but I'm trying to contain my excitement in the most genuine way possible around HUBzero. And every single one of these presentations, I'm obviously biased, but I'm also very enthusiastic about all things cloud. And I just see the role that AWS and cloud computing can play in so many of these presentations. Carol, as a geographer, going through your presentation, if you want to see me beg later, I will be begging Carol to figure out how to get her GeoHub to run on AWS. I mean, there's just so many applicable services and frameworks that make sense for HUBzero's platform. A great example is our GPU service. Instead of going through a long process for thinking about whether or not you should use GPUs or if GPUs could play a role in your hub, you can try them out in AWS for cents on the dollar for a couple hours and answer that question a lot quicker. And that's really the value that AWS, I think, is bringing to higher education and to scientific computing and research, where you can become a lot more agile and try new things. You spoke earlier about the time to science. And with AWS and access to that infrastructure and all these innovative things that we do on our side that we then make available to any customer of Amazon Web Services, it's just really incredible. So I could just talk randomly about this stuff, but I do want to kind of hit a couple high-level points, and hopefully I'll be able to kind of wrap some context around HUBzero. But at the very basic level, when we look at cloud computing, I think the technical definition is machine-to-machine interaction over the internet, and then the little caveat there is typically offered in a pay-as-you-go or utility-type service. The way Amazon looks at it is that machine-to-machine interaction. It is a pay-as-you-go utility model, but with AWS, it's a model where you don't have to make any large or any upfront purchases to get started. You are only billed for the things that you actually consume. So you don't need to buy a petabyte of storage to work up to a petabyte. If you use a gigabyte in AWS, you're only going to be charged for a gigabyte, or hopefully you're using a grant of some sort and you're not having to worry about the charge at all. With AWS, we'll talk a lot about, just not here, but on any given conversation, about elasticity and scale. And I'm going to talk about our scale in a couple slides here, but the elasticity is what's critical. The ability to create an infrastructure that can seamlessly breathe in and out with the needs of your application. Michael was talking about this earlier with the renderer and the toolkit. As your class logs on and you have 400 students using your hub, being able to scale up resources to meet that demand, but then more importantly, when that class is over, being able to turn those resources off all the way back down to zero. So it's really a critical component of AWS in our view of cloud computing. And the last two here are closely tied. This idea that you have access to this infrastructure and these different types of services creates a lot of value for universities, government agencies, obviously, and the organizations and startups that use them. The fact that you can get rid of those kind of longer procurement cycles, you have access to innovative technologies, like a GPU service that you just want to try out and make a decision on. That's really where a lot of our work got started in the scientific community arena, was with NASA. So they wanted to be able, their researchers wanted to be able to run Monte Carlo simulations. So if you have a really good idea, or maybe it's a really bad idea, you just don't know, you want to be able to launch that simulation. If you like what you found, you can run with it, and now you have justification to run with it. If things didn't pan out the way you initially thought, then you scrap it and you move on. So I think that's pretty clear. But so AWS has over 50 different cloud services. I'm not going to go into a detailed approach of any of them right now. All accessible over the web, so whether that's within your AWS management console or whether it's through the CLI. So anything that you would typically do in a data center is now available to you as a cloud service or a web service. All of those 50 services are backed by an API. So now you can begin to look at infrastructure as software or almost programmable hardware. And I want to talk about kind of these three different areas. I'm not going to do a deep dive into the actual services, but I put some information here on our networking services. So when we talk about networking or compute or storage, we actually are referring to possibly a few different services within that category. And you can begin to take advantage out of all of these, either, like I said, through your API or the management console. But I wanted to highlight networking, compute, and storage, because I think those are a lot of the key components that play with setting up a hub. So within each of these areas, you have multiple options for setting up your hub, whether you want to run it on a single core free instance or whether you want to run it on a very powerful one, or maybe you're going to launch a visualization or analysis tool that's going to be spread out over hundreds or thousands of EC2 instances. There's all these different options within AWS. But at a broader scale or a broader view, this is kind of what we do. We have this very broad, very deep set of web services. So looking at the bottom, it's all really based on our global infrastructure. I'm going to talk about our global infrastructure on the next couple slides. But then once you understand that, you now have a couple different ways to connect to that global infrastructure. So there's a few different networking services. And then you have our building block services, so compute, storage, databases. And on top of that, you have all these application services. This is really where a lot of the value of AWS comes into play, where we're doing things like Elastic Beanstalk or a container service, things that developers really like to have at their fingertips that used to be a big, big lift to get that type of functionality, and now that's a service, queuing or notifications. And then, of course, we offer a number of different services to actually manage all of the resources that you've deployed within AWS. But let's, here's our global infrastructure. So there's a lot to talk about here. I'm not going to dive into it right now, but there's 11 different regions. That's an important note to understand. And the way we kind of describe a region is a cluster of data centers. So each region is then divided up into what we call availability zones. So the easiest way to understand an availability zone is as a singular data center, when in fact each availability zone is made up of multiple data centers. And this is important from a hub standpoint, because if you need to build high availability or fault tolerance into your application or your website, this architecture of regions makes it really easy to do that. So you can have one instance running in availability zone A, and you can have a failover instance running in availability zone B. If anything were to happen to that hardware or that availability zone, you're going to automatically fail over into the other availability zone and never miss a beat. And the ability to do that, this failover, costs pennies. It's pretty incredible. So like I said, each region is made up of different availability zones. I jumped ahead of my slides here. Multiple data centers, at least 2 data centers within each AZ. There's more statistics about the amount of servers per data center and all that. If you're interested in it, we can chat later. But to give you an idea of the scale of that infrastructure, in 2004, Amazon was a $7 billion e-commerce company with 10,000 employees. In 2014, on average, we are racking and stacking enough server capacity to support Amazon as a $7 billion company. The amount of infrastructure is absolutely incredible. And it's important to note that it's not incredible, and I'm going to reference a couple large-scale kind of scientific computing use cases, but the scale isn't just for running 100,000, 50,000 core research jobs. The scale is important because it allows us to reach new economies of scale, and it allows us to continually drop our pricing, which we've done over 46 times. And that's important because it makes it a lot more affordable for any organization, whether it's a research department, a startup, or a federal agency. It continually allows us to drop our pricing and be the lowest cost option. That's really, I think, the most important part about our scale. It's not about muscle, it's about economies. So within the US, I was speaking about those regions. We have 4 different regions within the United States. We have 2 on the West Coast, 1 on the East Coast, and then we have a 4th region called GovCloud. All of those regions are built to an Amazon Web Services spec, but we also have all of this security and accreditation. So whether it's FIPS, or whether it's ITAR within our GovCloud region, FISMA Moderate, a whole host of Department of Defense security accreditations that I can't pronounce or remember. All of our infrastructure meets those levels of security and compliance. But then we also provide a number of different security-related services that allow you to make your application as secure as possible. So, like I said, the scale is really interesting. Last year, we used it to stitch together a cluster and made it onto the top 500 supercomputers. Ready in 100 seconds, costs you $100 an hour, and more importantly, once that test was run, you can turn it off, and you don't have to worry about maintaining that cluster. But we're not just used for scale, right? We're used by a lot of different people. It's really interesting. There's, when you look at infrastructure as a service, Amazon is responsible for everything from the physical location of our data centers all the way up to the hypervisor. And then after that, it's up to the customer to figure out what they want to do. And the result there is a ton of different interesting use cases where, we're spinning up a top 500 supercomputer, but Pinterest is launching a new application, and every little pin that you save is being stored in S3, one of our storage services. So the amount of use cases that occur is absolutely incredible, and it's really, really exciting. The other side of that is government and education. So I think we have over 4,500 universities that now run some type of workload on AWS, hundreds of government agencies and state governments as well as local. So I'm going to focus a little bit now on education specifically. We're seeing the education technology market adopt AWS and do some incredible things. So Coursera, I'm sure everyone has heard of, as well as edX and 2U. So these are platforms that run on AWS that are enhancing the in-classroom experience. The University of Notre Dame is an absolutely terrific customer of ours who is outspoken in their use of cloud and how it supports their school's mission. And one of the first things they did was they migrated their website over to AWS. And I think a couple weeks later, they were in the national championship for college football. Their web traffic spiked up through the roof, and they didn't even have to check their architecture to make sure it was running. They just knew it was going to work. And they didn't have any issues. This one is kind of how AWS is used in the classroom. This is one area I'm particularly interested. It translates really well to most any piece of software, but I often find myself talking about GIS. Working with the University of Michigan, they're launching a new training lab next week, actually. And their goal is to train 400 students over the course of a month on the new Esri GIS tools. So they're going to have, every single student is going to have access to a server, a desktop, and be able to learn, all the new things with Esri. And they're going to do it in, 30 student chunks. And it's just an absolute ideal scenario for AWS where they can provision these resources, spin them up, use them for the workshop, spin them back down, and then turn them back on for the next batch of students. So how are we being used in scientific computing? I think can get broken down into these different bullet points. It was funny, when I was doing my slides earlier, I was like, hey, you know what, I'm going to highlight collaborative research environments and science as a service, because I think that's really, analogous of, a hub and kind of what a hub can actually do for its users. But then I'm sitting here listening to all these presentations, and a hub can do all of these. And so one of the questions that we get a lot in a lot of our time that we spend working with universities is when we talk about all these capabilities, all the scale, all the research, all the data storage, all these innovative services, people kind of get it. They're like, yeah, that's great, but how do I do it? Like, how do I bring this to my university, or how do I get this to my customers? Like, I don't want to teach them how to each build their own cluster. That doesn't make a lot of sense. And so the more I look at hubs, I think more and more it's going to be a way that universities can deliver kind of the power of AWS to its community, whether that's launching a MOOC or doing an HPC or HTC analysis through the hub, whether it's a geospatial analysis that's being spread over hundreds of cores. I just think that what you guys do is just an absolutely perfect wrapper and platter, for better lack of words, for what's available in AWS. So, we're across the board. We have a number of different use cases within education. Harvard Medical was one of our first doing genomic analysis. They use, and often in scientific research and computing, they use what's called our spot market. So spot is basically the excess capacity that we have in our data centers that you can buy at incredibly cheap rates, typically. It's an open market, so it does fluctuate, but savings of up to 90% compared to the traditional on-demand rates of our EC2 service. Globus was mentioned a couple times there. Globus runs on AWS. We work very closely both with the Globus Genomics and the Globus Online in Ian Foster's group. They do an absolute wonderful job of preaching the benefits of AWS, and they do, I think, a terrific job of making science as a service available to their end users. Knowing I would love to talk to you later about what you're doing as well. There's just so many different parallels. But we have a lot of different partners out there, whether it's AmpLab, DNA Nexus, so many in the scientific research realm. And that's the vision that I have for HUBzero, is that you're going to be a partner, hopefully as prevalent as Globus is, where we're talking about, oh yeah, it's a hub that runs on AWS for whatever it is, GIS or whatever. Cycle computing is one of the large-scale examples that I wanted to highlight. So this is probably more of the muscle type example. But at our user conference last year, they announced they had done a 100,000 core processing job on behalf of a pharmaceutical company. They ran it for 18 hours over, I think, most of our regions, if not all of them, leveraging our spot market. And they did 18 hours of compute for $33,000. Schrodiner threw out some statistics like they felt like they did 265 years worth of computation, which I kind of giggle at that just because my brain is too small and I can't really wrap my head around it. So there's some interesting facts that came out of there, but more importantly, they actually they get their findings. They get their findings quicker. Their time to science and progress is a lot quicker. We mentioned, or Michael mentioned, the marketplace. So all these different partners, whether it's Cycle, whether it's HUBzero, whether it's Globus, all of these research computing partners can typically be found on the Amazon Marketplace, and the AWS Marketplace, excuse me. The AWS Marketplace is basically the app store for AWS, both ISV, for cost or for profit pieces of software, as well as open source software is available. And the kind of the last, this notion and slide is pretty silly, or just kind of generic, I guess, but I used this last year when I presented at Esri's user conference, and it's just such a simple kind of concept, but it's something that I think in the research space and in the higher education space, and absolutely in the state and local government space, is something that's been sought after, and that's how do we easily share massive sets of data, or just whole sets of data. Within the GIS realm, it was, I remember talking with the, I think it was the head of data services at WashU, and they were also one of the main, repositories for authoritative state GIS data. And, they were sharing that data over an FTP site, and they have a local GIS, admin trying to download a LiDAR cloud over FTP. And they're calling, I can't get the whole cloud, why not? And it's crazy. So GIS is just a really good example of this. But whether it's a repository, managed by a university of GIS data, or whether it's, the Landsat data that you have in the GeoHub, this concept where you can put an entire data set into the cloud and then share that out is really, really powerful. And it can take a number of different forms, whether these researchers, EDU partners, and government partners, that could be an app, that could be a website that's pulling from a centralized bucket in AWS. And there's a native feature of this storage service, S3, called Requester Pays. So if that application is running in AWS and that Requester Pays function is turned on, any usage of that data by the other account is going to be billed to the other account. So the owner of that bucket doesn't have to worry about footing the bill for all of the usage. So this idea of having the centralized storage where you can get access to entire data sets, and it's tightly coupled to this near infinite amount of compute where you can do analysis on that entire data set. I think it's extremely exciting. And I think the more applications we see, like HUBzero, that can take advantage of this type of really simple architecture is just incredible. So kind of blew through a lot of different pieces of information there. But again, thank you for having me. There's a ton to talk about with AWS and higher education, so thank you.